Hello again, welcome to video number 2 in magnetic fields, where we're actually going to look at magnetic fields. We're going to learn what they look like and how to draw them. So it should be short and sweet, hopefully, not 20 minutes worth. What do magnetic fields look like? Well, hopefully we've all had a go at doing this in primary school, high school, where we get a bar magnet, sprinkle some iron filings on it, and this is the sort of pattern that we get. Now notice, and we'll do this in class as well, just to reaffirm that we know what we're doing. Now notice here we can't tell which end is north and which end is south, but we can see that there's a concentration of field lines or magnetic field down at the ends, and there's not much happening in the middle, and then we seem to have continuous lines. Like if we were really careful with the iron filings, we could get them to be continuous, and these iron filings are acting like little mini compasses or mini domains as well, and so they're showing us what the field looks like. And so take a snapshot of that. That's what that looks like. Now this one's a bit more complicated, and we have to work out, now it could be two like poles or two unlike poles. So it could be a north and a north, or a south and a south, or it could be a north and a south. What is it? Well, a couple of clues here are that the field lines go up and join. Alright, and so we can imagine that we can almost see field lines coming up here. Let's try and draw these. This might be a bit techy, but we'll see how we go. Let's make this a nice colour. And so we can sort of see field lines coming up here and going down there like that. Bit shaky and like that. So that's telling us that they must be unlike poles. So we could have a north there and a south there. And if we look very carefully, we can sort of see iron filings going across. Okay? And that means that there is a magnetic field in that area. It's just that it's so strong that the iron filings haven't stuck to the paper. And when we do this in class, you'll get to see that as well. Alright? And so we would say that's two unlike poles. Next one is what happens when we have two like poles. So this could be two norths or two souths. And what's happening here is, if you look down here, the field lines come in here and then they sort of disappear, but you can just see a trace in there. So they go like that. And we could, because I know, like there's a good clue there. Goes like that, and so we've got field lines that sort of go like this. And so effectively we could put the highlighter on again, and let's make this really big. Well, let's see if that works. This area here, there's sort of no magnetic field, even though it sort of looks similar to the last one. When we're sprinkling iron filings on it, they wouldn't want to stay there, they get swept away. And we'll do this in class, and you'll get a better idea of this in class, folks, so be patient with us. Whoops, I'm clicking everything over here. And lastly, we've got one which is a horseshoe magnet, and a horseshoe magnet is effectively just a bent bar magnet. And why do we have horseshoe magnets? Well, the main reason is that this area between the two poles gives us a nice uniform magnetic field. And you can see there's a concentration of iron filings in this area. It also makes it nice and strong, which is really useful. And again, we can see, we can see field lines coming up and around. So we can't tell which one's north and which one's south, but we can tell that they're unlike poles. And notice there's very weak magnetic fields around this area here. For a horseshoe magnet, it's all about this area just here. So how do we draw them? Well, there's a very simple rule. Field lines always go from north pole to the south pole when external to the magnet. So when they're on the outside of a magnet, we draw them from north to south. A little bit different from electric fields. So here's a little diagram. There's our north, there's our south, and we draw our field lines. They come out of the north and they go into the north. They don't have to be continuous lines. We know that it gets effectively very weak as it goes further away, and we'll learn the equations for that shortly. And notice also, again, we don't have to draw multitudes of lines, just enough to show the general shape. and each line has to have an arrow showing the direction of the field line. Now, which way are they inside the magnet? Well, if we drew it, let's get a yellow again, it would go inside the magnet. It goes from south to north, just to confuse you. But that, we understand that because they've got to be a continuous loop. Alright, now so here we've got a couple. We're going to do mapping field lines and do some demonstration with magnets, which will reinforce all this learning, hopefully. And we'll be doing this in class, but we won't be doing the compasses and the iron filings simultaneously, and we will try and have a piece of paper between the magnet and the iron filings because it gets really messy otherwise. That's a pretty good effort. Okay, so there's a couple of videos there for you to watch on the OneNote. This one here is called Science Gym. It's just some dad made his kid do science in front of a video camera, but it's alright. And this one is a little Java application which will be on the OneNote as well, and so you can model what we're actually going to do in class as well, but in Java. So what would the magnetic field look like in this situation when you've got a bar magnet and a horseshoe magnet? Well, how I would draw it is get my pen, let's go for yellow, no green. Okay, so we're drawing them externally, and field lines will go from north to south. So we can put in the simple ones first. Okay, and they're also going to come out of the north, and they're also going to go into the south. Let's actually change the color a little bit. And they're going to go from north across here to the south, but they're also going to go across here. So we're going to have an area there of a bit of confusion. But notice that we're not crossing any field lines, and we're just filling in. We draw our straight ones first, and then we put in some loopy ones, and then some coming in to the south, and some coming out of the north, and that will effectively go into there as well. Alright, and that's all we have to draw. Don't have to get too complicated about it. Okay? Making sure that we've got arrows on them, and we're not crossing. Let's do the next one. So in this case, maybe you might want to pause it, have a think about it, and then I'll talk about what's going to happen. So pause it anytime now. Okay. So here we've got 3 souths, so they're actually going to repel each other. And the field lines are going to be a bit tricky, but the field lines are they can't go anywhere, they've got to make their way up to the north. So they're actually going to come out and around, and go out and around, and so they're not going to, when we've done this with iron filings, you'll get the idea, because you'll be actually able to see the iron filings follow these paths, because they don't really want to stick there. And we get this area here which is interesting, because effectively all the field lines are cancelling each other out, and there's no magnetic field. So you don't really have to draw much more there. If you want to, you can put your norths and you can fill it in a bit more, like so. But this was the key thing to notice there. Alright, let's get rid of that. So we've got a video now, what happens when you put a magnet on a TV. It's called Magnet on TV. And the TV is an old cathode ray tube, so you can see what's actually happening. So you might be able to apply some of your understanding of cathode ray tube TVs and magnetics into it. It's what not to do, basically. And in the next video we're going to learn about the Earth's magnetic field. So that should pretty much do us today.